So here at RIT, we have an emerging interest in 3D printing. As recently as 5 years ago, there was very little 3D printing activity here on campus. Now we've got numerous faculty members. Almost every college on campus has pockets of 3D printers, and students are using these printers extensively for different design projects, very much multidisciplinary. Some of the big trends in 3D printing, a lot of people think that 3D printing is new. It's actually a little over 20 years old, and what happens at 20 years is patents expire, and when patents expire, people can all of a sudden afford the machines. So the industries that are currently most affected by 3D printing are aerospace, metal parts, very lightweight metal parts in aerospace, and biomedical. So custom implants and hearing aids and braces and things like that. For the future, kind of the next wave of industries to be affected by 3D printing, color is a big one. There are full color 3D printers, so pretty much any consumer goods, from a computer mouse to a blender, anything like that where you can customize it, embedded electronics and things like that, is going to become a big deal in the near future as well. So I think the future is very bright for 3D printing, not just here at RIT, but for the region. There's a tremendous amount of collaboration between RIT, University of Rochester, and our local business that are looking at opportunities for materials and processes and applications that take advantage of 3D printing technologies that do things that you can't do with any other process. So we're very excited about where things are headed, and we intend to play a major role in that with the Rochester region. So this is an example of using a student project using 3D printing to try to improve on the padding in a football helmet for concussion prevention. So we take instead of using standard padding here, we can 3D print padding that's exactly the right size and thickness that you need. And we can 3D print different geometries and material properties here to try to do a better job of absorbing the impact energy. So the students have designed an impact tester here where they test their 3D printed padding, where this gets raised up in the air and then it drops it, and there are sensors in there that measure how much impact force was exhibited in the helmet, and that lets them then iteratively redesign better padding. So this is an example where we can use 3D printing to print a custom bone plate for a skull fracture. And this would ordinarily be printed in titanium, but this is just a plastic model that the students designed and 3D printed to show the concept. Here's an example. This is actually titanium, and you can see this hollow interior, so it's very, very lightweight, but it's engineered to be extremely strong. So this is great for aerospace applications where you want to save fuel and reduce CO2 emissions. Here we have an example of a 3D printed prosthetic hand for kids that might be born without fingers. And they put their wrist in there, and when they flex their wrist, it grafts with the fingers. And so this is very inexpensive, and it allows kids who are still growing to have a prosthetic hand at very low cost.